Evening to everyone, and welcome to the today's TNSET online class session. I'm thrilled to see all of you eager to wait for our today's class. Okay, so today we'll exploring the Unit 1, the sequence and series. This topic forms a crucial foundation in our journey towards mastering the TNSET exams, and I am confident that with our collective efforts and dedication, we will navigate through the success. Short introduction of our today's guest. It is with great pleasure that I introduce our esteemed guest for today's session, Dr. S. Kohila, Triple B College, and ma'am belongs to the Department of Mathematics at Triple B College with the impressive track record of 6 years of service in the field, and her specialization is topology. And Dr. Kohila has made significant contribution to research with the numerous publications in both national and international levels. And moreover, she presented her work at various seminars and conferences and various colleges. And also, ma'am has a wealth of knowledge and experience. We are truly honored to have Dr. Gokila join us today, share her insights and expertise through the TNSET examination. And also, one of the extra additional point, ma'am has completed, ma'am has qualified TNSET in 2016. Okay, so thank you, ma'am, with our Infinity Research and Development Institute and Indian Mathematics Professors Association. I welcome you, ma'am.
Thank you, sir. Thank you for welcoming, sir.
Yeah. Can we
Can I
start the
start now,
session,
sir?
ma'am? Yes, ma'am.
Thank you, sir. I am Dr. Kohila, Assistant Professor of Mathematics, PB Vanitram College for Women, Delhi. In this session, I am going to take a topic on sequences in series. First of all, we will see the basic definition of sequences. This is the main definition of sequence. A function, another name of the function is mapping from the set of natural number to or defines a sequence of real numbers. It can be denoted as f from n to r is a sequence of real numbers. Always sequence can be denoted in this form, that is cap symbol. In between cap symbol we have to write these sequences, that is f of n. It is the general form of sequence, f of 1 comma f of 2, like this. Let us see one example, that is an. It is the sequence an equal to n. You can substitute any number for n. It may be natural numbers or real numbers, whatever it may be. Then the second one is an equal to minus n, which means the sequence represents the set of negative numbers. That is, sequence represents which positions you have to allot for that particular number. Such type of representations are called the sequences. Next, we will see the definition of range set of a
Sorry
sequence.
for the
The range set of a sequence means it is an output, that is codomain. The range set of a sequence is the set consisting of all distinct elements of a sequence and with regard to the position. Let us see this notation, that is un. R of un represents the range set of the sequence un, which means u1, u2, u3, etc. n belongs to capital letter n. These are all the examples of sequences. an equal to 1 by n. Then the sixth one is an equal to 1 minus of minus 1 power n by n. And seventh one is when the position of prime numbers you have to put 2, and any other cases you can put n, that is nth position. Can anyone tell the sixth position of this sequence? Anybody? What is the sixth position of the seventh example? Anyone else?
Ma'am, we can continue, ma'am. This is only the recording process.
Okay,
So
sir.
after the
Okay, sir.
stream
Fine.
only, after the session only, we'll
Okay,
stream
sir.
that.
Okay, sir.
Thank you. Kindly make it as a full screen mode, ma'am. The slideshow
Okay.
option. Okay. Thank
Next, these are all the few examples of the sequences. an equal to cos n, an equal to sin 1 by n. These are all the examples. Next, look at the 18th example. An equal to minus 2, minus 3, minus 1, 0, 1, 2, 1, 0, 1, 0. This is an unbounded sequence. Next, we will see the definition of bounded sequence. We know the word bounded itself says it has a limit points, which means lower limit and upper limit. The basic definition of bounded sequence. A sequence UN is called bounded if its range set is bounded. That is, if there exists real number k, that is lower limit, and upper limit k, such that that sequences belongs to, that is limit points are lower limit, the sequences lies between lower limit and upper limit. Otherwise, we can say if there exists k greater than or equal to 0, such that modulus of un less than or equal to k for every n belongs to n. You can take any one of these definitions. Next, supremum. Otherwise, we can say least upper bound of the sequences defined as the supremum of the range set, and the infimum of the sequences defined as infimum or greatest lower bound of the range set. Next, if the range of the sequence is finite, then there exists some number, that is alpha, that belongs to the set of real numbers, such that an equal to alpha for infinitely many values of n. But this converse part is need not be true. In case that is the an equal to alpha, definitely we can say that given sequence is finite. It may be finite or infinite. Look at this example. When n equal to 1 or prime number, the result is, that is, you have to substitute the value 4, and other places you have to put n. Here an equal to 4 for infinitely many values of n, but range of the sequence an is not finite. This is a good example for this previous statement. Next definition is an important one. Monotonic sequence. Monotonic means the word refers as either increasing or decreasing. Increasing means non-decreasing. If you want to say the given sequence is monotonic, this is the main conditions. These conditions are very important. That is an less than or equal to an plus 1, which means the successive terms are greater than the predecessor, that is previous one. Such type of sequences are called the monotonically increasing or non-decreasing sequence. You can expect a lot of questions in section B from this sequence topic. So you can make it then. an greater than or equal to an plus 1 means such type of sequences are called the monotonically decreasing sequence. That is strictly increasing. Instead of less than or equal to or greater than or equal to, all the numbers are less than the successive, that is all the successive numbers are less than the predecessors, that is previous one, means we can say that this is strictly increasing sequence. Similarly, an greater than an plus 1 means that is strictly decreasing sequence. Let us see some examples for the above definition. Here an equal to n is a strictly increasing sequence. You know that you can substitute any numbers, all the numbers are greater than the previous one. So this is a strictly increasing sequence. Then the next one is set of negative numbers. Already we have seen this example in the previous slide. This is a strictly decreasing sequence. Look at the third example. an plus 1 is equal to root of 2 plus an for every n belongs to n. is a monotonically increasing sequence. You can check out this. Here A1 value is 0 because we are taking n belongs to set of natural numbers. Next definition, eventual nature of a sequence. This is a rare case, even though you can note it down this. A sequence AN is said to be eventually monotonically increasing. Right, that's what. Eventually monotonically increasing means an plus 1 is greater than or equal to an after some stage. That is, for every n greater than or equal to m. Look at this example. The use of example, you can understand these definitions clearly. Here, first question is 0, second place 2, third place minus 1. It is an oscillating ups and downs. Next, fourth one is 3. Then, fifth question is 7. Then, next question is 8. After the fourth question, when m equal to 4, the sequence is gradually increasing their values. That's why. So, particularly the fourth positions. From the fourth position onwards, the sequence is increasing. That's what this kind of sequence is called the eventually monotonically increasing. So vice versa, we can see the eventually monotonically decreasing sequence. So these two things are very important. Here greater than or equal to, here this is less than or equal to an plus 1 less than or equal to an. Look at this example. Here also fifth position 1, then sixth position automatically decreasing half part. That's 1 by 2, 1 by 3, 1 by 4. The next place is 1 by 5. So after m equal to 5, the sequence is decreasing. That's what this sequence is called the monotonically decreasing sequence. You can note it down this. Next, a sequence AN is eventually constant sequence if there exists m, that is certain position, belongs to n such that AN equal to C. Here C represents the constant. After some stage, all the places we have to put the particular number. Such type of sequences are called the eventually constant sequence. Next important concept of the sequence, limit point of a sequence. A real number P is said to be a limit point or a cluster point. Already we know this. Cluster point of a sequence, the same definition. If every neighborhood of P contains, that is x minus delta comma x plus delta, that is called every neighborhood of P contains an infinite number of elements of the given sequence. If it satisfies this condition, then we can say that particular number or particular point is called the limit point of our sequence. Unless otherwise, that is not a limit point. The same definition can be represented as real number P is a limit point of a sequence AN for any epsilon greater than 0. That is Uranus's definition. AN belongs to P minus epsilon comma P plus epsilon. That sequence belongs to this interval for infinitely many values of n. In case finitely many values of n, then we cannot say that real number P is not a limit point of the sequence. Note it down this. The next note, remark. A real number P is a not a limit point. If we want to say the number is not a limit point of our sequence means the important condition, there exists at least one neighborhood of P which contains only a finite number of elements. Each and every neighborhood of P contains infinitely many values. Then only we can say that particular real number is a limit point of the sequence. Otherwise, one neighborhood of P contains only a finite number of elements. Then we can not say the real number is not a limit point of the sequence. So important thing, you can see the options in section B. Limit point of a sequence need not be a limit point of the range set. It's very, very important. Look at this example for the previous statement. If an equal to minus 1 power n, so we have the sequence when n equal to 1, first place minus 1, second place 1. All the even places we have positive 1 and all the odd places we have minus 1. So 1 comma 1 minus 1 is a set of limit points. But at the same time, 1, neither 1 nor, this is not, minus 1 is a midpoint of its range sets. The sequence has a limit point, but the range set has a not limit point. அதாவது ஒரு சீக்வன்ஸ்க்கு லிமிட் பாயிண்டா இருக்கிறது ரேஞ்ச் செட்டுக்கு லிமிட் பாயிண்டா இருக்கணும்னு அவசியம் இல்லை. பட் ரேஞ்ச் செட்டுக்கு லிமிட் பாயிண்டா இருக்கிறது சீக்வன்ஸ்க்கு லிமிட் பாயிண்டா இருக்கு. That limit point of a sequence can be obtained in 3 ways. What are all the ways we can obtain the limit point of the sequence? First one is representation on real line. For second way, if the range set has a limit point, just now I said, range set has a limit point, definitely the sequence has a limit point. The third one is range set is finite, n equal to alpha for infinitely many values of n. Then alpha is a limit point of the sequence. Range setல இந்த சீக்வன்ஸ் ஒரு குறிப்பிட்ட பாயிண்ட்ல போய் கன்வெர்ஜ் ஆகுது, நிறைய வேல்யூஸ் போறப்போ அதே நம்பர் திரும்ப திரும்ப கிடைக்குது அப்படின்னா நம்ம அந்த சீக்வன்ஸ் லிமிட் பாயிண்ட் அந்த பர்டிகுலர் வேல்யூஸை நம்ம எடுத்துக்கலாம். இதுதான் அதோட மீனிங். Next section, Bolzano-Weierstrass theorem. Theorem statements are important. Every bounded sequence has a limit point. It's a very important one. Note it down this. Every bounded sequence has a limit point. இப்போ உங்களுக்கு ஒரு சீக்வன்ஸ் கொடுத்து அந்த சீக்வன்ஸ் ஃபர்ஸ்ட் பவுண்டடான்னு மட்டும் பார்த்தாலே போதும், இதுக்கு கண்டிப்பா ஒரு லிமிட் பாயிண்ட் இருக்கும். What is the reason this? Since the sequence an is bounded, range set of an is also bounded. You see, this is second one. First case, if the range set is infinite, we can use the above theorem statement. If the range set is infinite, then by the Bolzano-Weierstrass theorem, range set must have a limit point. So the sequence has automatically, sequence has also a limit point. The sequence has also a limit point. Second case, if the range set is finite, it is the third way of limit point sequence. And the மூணாவது point use பண்றோம். If the range set is finite, then there exists alpha belongs to R such that an equal to alpha for infinitely many values of n. Evidently, alpha is a limit point of this sequence. These are all the applications. We can note it down this. Out of these three, we can have any one example in your exam. An equal to minus 1 power n is bounded. We know that it has limit points 1 and minus 1. So lower limit and upper limit is existing. So the sequence is bounded. Then bn equal to 1 by n. This example is known everyone. Its limit point is 0. 1, 1 by 2, 1 by 3, 1 by 4. It converges to 0. Then the third example is 1 by n the whole power n has a limit point e. You can check it out whether it has a limit point e or not. You can try it yourself. This is the third one. It's important to note. Unbounded sequence we may have limit points. இப்போ பவுண்டட் சீக்வன்ஸ்க்கு தான் லிமிட் பாயிண்ட் இருக்கும் அப்படின்னு நம்ம கான்ஸ்டன்ட்டாக சொல்ல முடியாது. அன்பவுண்டட் சீக்வன்ஸ்க்குமே லிமிட் பாயிண்ட் இருக்கு, நோட் பண்ணிக்கோங்க. நெக்ஸ்ட் டெஃபினிஷன், சப்சீக்வன்ஸ். சப்குரூப் சப்செட் மாதிரி சப்சீக்வன்ஸ் அதே மாதிரி டெஃபினிஷனும். Consider a map f from n to n defined by f of k equal to nk. Let nk be a strictly increasing sequence of natural numbers. Then, for any sequence an, the sequence ank is defined as a subsequence of an. Ank is a subsequence of an. Look at this example. Let a an be any sequence of real numbers. This is set of even numbers. This is set of odd minus 1 power n, and the second sequence is minus 1 power n plus 1. Both are not convergent. You can check it yourself whether both are not convergent or convergent. That is a and b n. You can take product variable sequences. This is minus 1 power 2n plus 1. That is a power n into a power n plus 1. That is n plus 2n plus 1. This is convergent. There are very important rules you can try it yourself. Separately, both are not convergent. When you are taking the product, you will get convergent sequence. It's understood, Sandra. It's the same sequence minus 1 power n, then minus of bn, minus of minus 1 power n plus 1. Which result is two sequences converging the point 0. This next statement 7.21. Every convergent sequence is bounded. Can expect this statement in point B. Every convergent sequence is bounded. Look at this example. A equal to minus 1 over n, then A is bounded but not convergent. Next point. This point. Limit of a convergent sequence is unique. Limit of a convergent sequence is unique. L is a limit. You can tell every neighborhood of L is
Ma'am,
only. Sir,
ma'am, the two devices are unmuted, ma'am. Voice echo ஆகுதுங்க மேம். ரெண்டு டிவைஸ் unmute ஆயிருக்கு.
okay,
Okay,
sir.
okay. Now okay, ma'am. You can proceed, ma'am.
Can I continue this?
Yes, ma'am. You can continue.
Second point, limit of a sequence is a limit point. Important. The limit of a sequence is a limit point, but converse may not be true. Look at this. If limit n tends to infinity, un equal to L, this implies limit n tends to infinity, un equal to modulus of L, but converses may not be true. Same thing, it can be represented, that is the previous statement, eighth statement can be represented in this way, 9th one. It's the 10th one. If the sequence un is less than or equal to vn for every n greater than or equal to n, and limit n tends to infinity, modulus of vn equal to 0, then limit n tends to infinity, modulus of un is also 0. Note down this. That is, one sequence is less than or equal to another sequence if that is the large sequences maximum value sequences converges to 0, then that increment sequences also converges to 0. இந்த மாதிரி கொஸ்டின்ஸ் கேட்டாங்க அப்படின்னா நீங்கள் வந்து ஒர்க் அவுட் பண்ண வேண்டியதில்லை, அந்த ஸ்டேட்மெண்ட் ஞாபகம் இருந்தாலும் நீங்கள் ஆன்சர் பண்ணிக்கலாம். நோட் பண்ணிக்கோங்க. If limit n tends to x, an equal to a, and an greater than or equal to b, there is in the number. For every n greater than or equal to m, when m belongs to set of natural number, then a greater than or equal to b. This is also important one. Listen carefully. Limit n tends to x, the sequence is converges to some point A and the sequence is greater than or equal to B, then that limit point of a sequence is greater than or equal to B. இந்த மாதிரி ஆப்ஷன்ஸ் கேட்பாங்க, கொஞ்சம் கவனிச்சுட்டு அதுக்கப்புறமா ஆன்சர் பண்ணுங்க எப்படி கொடுத்துருக்காங்க அப்படிங்கிறது. இது எல்லாமே கொஞ்சம் நல்லா ப்ரிப்பேர் பண்ணிருந்தீங்கன்னா உங்களுக்கு ஆன்சர் பண்ணுறப்ப டைம் கன்சம்ஷன் ரொம்ப கம்மியாகும். நெக்ஸ்ட், a bounded sequence AN is convergent. It has unique limit point. It's very, very, very important. சப்போஸ் ஆப்ஷன்ஸில் 2 அல்லது 3 லிமிட் பாயிண்ட் கொடுத்துருக்காங்க, பட் நீங்கள் எடுத்துருக்க சீக்வன்ஸ் பவுண்டட் லிமிட் பாயிண்ட்ஸ் ஏதாவது லோயர் லிமிட் அப்பர் லிமிட் எக்ஸிஸ்டன்ஸ் ஆகுது அப்படின்னா ஒரே ஒரு லிமிட் பாயிண்ட் தான் இருக்கும். இது ரொம்ப ரொம்ப இம்பார்ட்டண்ட்டான 1 மார்க்கு நோட் பண்ணிக்கோங்க. ஸோ the above 12 statements provide a second definition for a sequence to be convergent. A sequence is convergent if it is bounded and it has a unique limit point. இது வந்து நீங்கள் ப்ரிப்பரேஷன் முடிஞ்சாலும் இந்த ஸ்டேட்மெண்ட் உங்களுக்கு ஞாபகம் இருந்ததுன்னா நீங்கள் நிறைய விஷயங்களை நீங்கள் மெயினாக தெரிஞ்சுக்க முடியும். இதை நீங்கள் அப்படியே ஞாபகம் வச்சுக்கோங்க. சீக்வன்ஸ் இஸ் கன்வெர்ஜென்ட். ஒரு சீக்வன்ஸ் கன்வெர்ஜென்ட்டாக இருந்ததுன்னா இந்த 2 விஷயம் கண்டிப்பாக இருக்கும். எப்படி நம்ம ரியல் காம்பேக்ட்னா உடனே க்ளோஸ்ட் அண்ட் பவுண்டட் சொல்கிறோமோ, அதே மாதிரி ஒரு சீக்வன்ஸ் கன்வெர்ஜென்ட் அப்படின்னாலே பவுண்டடாகவும் இருக்கும், அதுக்கு யூனிக் லிமிட் பாயிண்ட் இருக்கும். மோர் தென் 1 லிமிட் பாயிண்ட் இருந்தால் அது கண்டிப்பாக கன்வர்ஜென்ட்டாக இருக்காது. நல்லா ஞாபகம் வச்சுக்கோங்க. தனியாக படிக்கும்போது நீங்கள் குரூப் டிஸ்கஷன் பண்ணுறப்ப இந்த மாதிரி ஸ்டேட்மெண்ட்ஸ் எல்லாம் அடிக்கடி டிஸ்கஷன் பண்ணணும்னு வச்சுக்கோங்க. சஜஷன். நெக்ஸ்ட் அப்ளிகேஷன். If a sequence, it may be bounded sequence, has more than 1 limit point, then A and cannot be convergent. Just now I said, if it has more than 1 limit point, obviously we can say the given sequence cannot be convergent. Immediately நீங்கள் ஆன்சர் பண்ணிடலாம். மோர் தென் 1 லிமிட் பாயிண்ட் இருந்துச்சு அப்படின்னா கண்டிப்பாக நமக்கு கொடுத்துருக்க சீக்வன்ஸ் கன்வர்ஜென்ட்டாக இருக்காது. நீங்கள் லிமிட் பாயிண்ட் செக் பண்ணுங்கள், ரேஷியோ டெஸ்ட் டெஸ்ட் மூலமாக லிமிட் பாயிண்ட் செக் பண்ணுங்கள். அப்படி வந்து லிமிட் பாயிண்ட் 1க்கு மேலே வந்துச்சு அப்படின்னாலே கொடுத்துருக்க சீக்வன்ஸ் கன்வர்ஜென்ட் கிடையாது அப்படிங்கிறதுல ஸ்ட்ராங்காக நம்ம இருக்கலாம். திஸ் எக்ஸாம்பிள் an equal to -1 power n. It's very, very important example. இதே எக்ஸாம்பிள்ஸ் கூட சில எக்ஸாம்பிள் கேட்டிருக்காங்க, இதை வச்சு தான் நான் போட்டிருக்கேன். -1 power n is bounded. You know that the given sequence is bounded. Already we have seen this example in previous slides. And we know that 2 limit points, 1 and -1. So 2 limit points are there, which means more than 1 limit point. So obviously, that is undoubtedly we can say the given sequence is not a convergent sequence. The second example, Bn equal to -1 power n plus 1 by n is not convergent. You can try it yourself whether it has 2 limit points, 1 and -1. The first example is simple one. The second example you can try it yourself, then only we can get, that is we can get clear idea about that convergent concept. Next point, an unbounded sequence cannot converge to a real number. இந்த மாதிரி ஸ்டேட்மெண்ட்ஸ்லாம் திரும்ப 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 எழுதி பாருங்கள், உங்களுக்கு வந்து ரொம்ப யூஸ்ஃபுல்லாக இருக்கும் எக்ஸாம் எழுதுகிறப்ப. an unbounded sequence cannot converge to a real time. சீக்வன்ஸே அன்பவுண்டடாக இருக்குது அப்படிங்கிறப்ப கண்டிப்பாக ஒரு பாயிண்டில் போய் ஒரு ரியல் நம்பர் இல்லை ஒரு நம்பர்லையும் போய் கன்வெர்ஜ் ஆகாது. Look at this example for this second statement, that is unbounded sequence. And first check பண்ணிடலாம் unbounded sequence now. an n, that is 1 2 3 etc. it's going on. So this is an unbounded sequence because it has anything that is least upper bound does not exist for this sequence, so it cannot convergent. The second sequence is also not convergent. This again you can try it yourself. கொஞ்சம் நம்பர்ஸ்லாம் சப்ஸ்டியூட் பண்ணி பாருங்கள், கன்வெர்ஜ் ஆகுதா இல்லை டைவர்ஜஸ் ஆகுதா, எதனால கன்வெர்ஜென்ட் ஆக மாட்டேங்குது, மோர் தென் 1 லிமிட் பாயிண்ட் எக்ஸிஸ்டன்ஸ் ஆகுதா, இல்லை இது அன்பவுண்டடா, இந்த மாதிரி ஆப்ஷன்ஸ் நிறைய செக் பண்ணி பார்த்தீங்க அப்படின்னா உங்களுக்கே ஒரு கிளியர் ஐடியா கிடைக்கும். The third one is the sequence has a limit point, that is this type of domain, it is not convergent. Look at this example. Consider a sequence. This is a limit point 0, but an is not convergent. Try to find லிமிட் பாயிண்ட் இருந்தாலே கன்வர்ஜென்ட் ஆகணும்னு அவசியம் இல்லை. பட் கான்வெர்ஜென்ட்டாக இருந்தால் கண்டிப்பாக லிமிட் பாயிண்ட் இருக்கும். இன்னும் கொஞ்சம் ஞாபகம் வச்சுக்கோங்க. இந்த எக்ஸாம்பிள் கொஞ்சம் பாருங்க. This is that's the example for the above statement. That's a limit point 0. But it is not convergent because it is an unbounded sequence. 1, 0, 2, next 0, next 3, 0, 4, 0, next 5, then again 0. Then 6, 0. It is an unbounded sequence, but it has a limit point 0.
Institute and the Indian Mathematics Professors Association for conducting this type of program for young mathematician and researchers. Okay, so and also I would like to thank our participants for their reasonable listening. Okay, so dear participants, so prepare well. We'll clear the TNSET 2024. Thank you. Thank you all.
Thank you so much, sir. May I leave from here, sir?